Hello and welcome to a short demonstration of the crack and seam filling bot simulation in Tinkercad. I'm going to do a brief overview of what we have laid out for you and go through the code and then simulate to show how it all works. So we have our Arduino here, two ultrasonic distance sensors. This is explained in the description of the robot. It's measuring for a differential distance from a level sidewalk. So if it detects a crack, that's what we are trying to correct. We have our wheels here, one motor, one DC encoded motor for each side. So right wheels, left wheels, driven by an L293D driver, powered by, the motor is powered by a 9-volt battery. And we have an LED here, and this is to simulate a linear actuator. There is not a linear actuator provided in Tinkercad, so this is a discrete on-off fill. The linear actuator is designed to fill or actuate the epoxy canisters rather, and go through a spout and fill the crack until the level detects that we have a level surface, in which it will stop, and the bot will continue searching for more cracks. So a brief overview of the code: define some variables, differential distances, pins, right wheels, left wheels, pin modes, defining some serial information, differential. This is the difference between these two sensors. This is calculated down here. So just triggering or pulsing the trigger of each sensor, capturing the echo, translating it to inches, and subtracting one distance from the other distance. And this is defined as diff, which is a float we defined up here. So basically, if diff is less than a quarter inch or negative quarter inch, then we are going to call the epoxy out, which is this LED here, and our wheels will stop so we can fill the seam. And once it's done, it will continue. So let's take a look at the simulation, see how it works. As we start out here, you can see our wheels are turning. Our bot is moving, looking for a crack. We take a look at our serial monitor. Our differential is currently something that's not very realistic. We should be looking for a generally level playing field here, so around an inch. Wheels are still turning. As soon as we cross that threshold of negative 0.25, it's hard to simulate that, but we're down here below negative 0.9. Our wheels have stopped turning, voltage cut off for the motors. Our LED has came on, simulating that we are filling the seam. And as we're filling that seam, our level should continuously get closer to level. So to simulate that, I will pull this back up to, trying to get it to 0. Either way, it's a positive number. It said, hey, I'm good, stop filling, motors kick back on. You can, well, Tinkercad doesn't like these motors too much. They sometimes work and sometimes don't. But you can see this multimeter here measuring positive and negative of the motor outputs. We are sending voltage to the motor powered by this 9-volt battery. I assure you it's not an error in the code. It's had some problems with having too many outputs on here. Not liking to work. If I stop and start, I think they'll start turning again. Yep, there we go. So that's a general overview, high-level overview of how it works. Thank you for watching.